Forces change the speed, direction and shape of just about anything. Press start to begin. Whenever you push or pull, you're using a force. But isn't it odd that forces are invisible? However, even though we can't see them, we can see their effects. Just click on this apple. There it goes. It falls because there's a force acting on it. Forces change speed and direction of movement. And the force involved here is gravity. Gravity pulls the apple down towards the earth. Forces can change the shape of an object too, quite drastically in this case. Now, suppose you wanted to measure force. How could you do that? This spring is a good place to start. Give it a pull. We measure force with a unit called a newton. The N at the end of the spring weighs 10 newtons. The more force you use, the more the spring stretches, so we can measure force this way by measuring the stretch. Let's go back to gravity. But what is gravity anyway? It's a force that exists between all objects and pulls them together, but you only see its effects with really massive objects, like planets. Why? Because gravitational force is stronger the more mass the objects have and the closer they are. Planets exert a strong gravitational force on objects near to them. Take a look at this astronaut. Like all objects, she has mass, and her mass never changes. Weight, on the other hand, does change, because weight is a force and it depends on gravity. The moon is smaller than Earth, so it exerts a weaker gravitational force. Why don't you drag the astronaut to the Earth or moon and see what happens to her weight? On Earth, our 60-kilogram astronaut has a weight of 600 newtons. Now try the other one. On the moon, the 60-kilogram astronaut weighs a mere 100 newtons, about as much as a small dog weighs on Earth. Let's look at forces and movement now. The weight of this apple pulls it down, but the branch pulls it up. The forces are balanced and the apple stays still. It's exactly the same with the apple on this table. Its weight pulls down, but the table pushes up, so it's static. It definitely won't magically tunnel its way through the table or anything. How about this van? The forces are balanced here too. There's no force pushing forwards and no force pulling backwards, and we're not moving. Thrilling. But what happens when we deliberately unbalance the forces? Click the van to start it. Now there's a large force pushing it forwards and a small friction force pushing backwards. The forces aren't balanced anymore, and that's what starts the van moving. Unbalanced forces like this always cause changes in the way things move. Now watch what happens when we ease off the accelerator. We're back to balanced forces. The force forwards from the engine is equal to the friction and air resistance pushing backwards. So notice that when forces are balanced, it doesn't mean things don't move. Balanced forces mean no change in speed, so our van moves along at a steady pace. Until we hit the accelerator and unbalance the forces again. Ready for a refresh? Forces can change the speed, direction and shape of an object. Forces can push or pull. Forces are measured in newtons. Balancing forces. When forces are balanced, a stationary object stays still and a moving object moves at a constant speed. If forces are unbalanced, the object changes speed, direction or shape.